EAs are fundamental for traders who want to earn a passive income and for IBs. This presentation is all about, first, a couple of words about what EAs are today, and then a quite heavy story about what EAs are going to be like in 2024, because all these new technologies we've heard about during this year are coming through big time. Then I'm going to fit that into social networks and how they do their analytics, society, how we relate to our computers, and then come back into VPS and how we put the next generation EAs on top of StarTrader VPS. Good fun. Welcome. StarTrader, of course, is the company that has won a whole bunch of awards. I'm not going to go through all the details on that. We've already spoken about those things before. But fundamentally, let's go into why EAs are relevant. Well, with any analytics is geared towards creating a vision of the future. If we want to go ahead, it's quite good to know where we're going. So we want to anticipate future trends, make early decisions, see patterns. This relates to trading, of course. It relates to all of business and the way that we do our lives. EAs have an effect on all of these things, believe it or not. Now, with EAs today, there are a number of methods that we will hear about at all these conferences. We're going to hear about moving averages, going backwards a number of months, a number of days, a number of minutes or seconds. We're going to hear about Bollinger Bands. We're going to hear about relative strength indexes, RSIs, resistance levels, MACDs to look at momentum indicators, Fibonacci trading. Fibonacci happens to be quite a useful number sequence in some circumstances, and sometimes a couple of words about neural networks. Both our traders, Dayu in China, who is an avid basket fan, uses EAs a lot. She's running her academy for 25,000 customers. She has 25,000 friends on TikTok. I don't have 25 friends. That's life. And also Lucas in Brazil uses EAs extensively. He's super technical at what he does. Big football fan. Unfortunately, he doesn't support Chelsea, but hey, everyone hasn't grown up in London. So very relevant. What's going to happen next? Well, first of all, let's just think about what these next generation models are all about. We provide an input, such as asking a question, and this input goes into some software. That software has been written either in R, if you're very mathematically oriented and heavy duty as a software developer, or in Python. Python is a simpler software that can be used for this. At this point, I probably scared you. That's okay. I scared myself as well. This is just the way it works. So we've given input, and that input goes into software, which sits typically inside an R framework written either in R or in Python. That's what happens. That software then pings an API to get a model. And there are these big models, these really powerful models that you can download and use for this. We're familiar with some of them. I'll go through some of them in a moment just to give us more. And behind these models, there is data. So there's a big richness of data sitting behind each of these models. Ultimately, the data feeds the model feeds the software that's been written for you, and you get a response. You can do this manually, where you put in a request manually, you get a response, or you can have an EA that does the whole thing. This is different compared to today, because we're not talking about a couple of if statements. We're talking about very advanced software that makes really complex conclusions about what to do next. These different models have opinions, just like EAs today. If you try one EA, you get one result. Try a different EA, you get a different result. Similarly, for these large artificial intelligence models, they all give different answers because they are different models and they use different data sets. So please don't expect these models to give the same result. They differ. On this slide, I have two examples. There's a model by Facebook called the Prophet model, which is a really powerful open source model that's been created by the Facebook engineers, and ARIMA. I did an analysis here on P/E ratios for a couple of stocks, and I got two different results. So ultimately, you get an error, which is the dispersion around the result, and these errors differ. If you want a good view, you probably want multiple models looking at the same problem. All of these models, just like today's EAs, have some similarities. Ultimately, what you do is you look at a big problem, such as the price of gold, you decompose it and split it up into different sub-problems, and then you solve these different problems in different ways. You do differencing, you do smoothing, you do regression testing and so forth, taking out seasonality and trends in different ways, and then you bring the whole thing back together again. So split it up, different ways of solving the problem, bring it together again, boom, there's your result. They have that similarity. Now, let's take one example outside the world of finance, first of all. El Niño is this fascinating and dangerous weather effect in the Pacific Ocean. Now, you can do measurements at equal time intervals throughout the El Niño season. That's called univariate. And take out the trends and seasonal effects, do a bunch of domain forecasting, bring it all back together, boom, and you have a result. So that's a typical way of using these models. To do that, you would be writing in R and you would be writing in Python. You would be using models to do all the work, and you would use data from everywhere. Data directly from El Niño itself, but also historical data, other data from the Atlantic, other data from the Indian Ocean, and so forth. Together, you would get a result. I take that example because it's similar to other examples that I'm going to go through right now. Facebook have a different problem. Their problem is that Facebook has lots of customers all over the world. They are in different groups. These different groups want to be served in different ways. So they created a model that they call Profit. It's a really powerful model. The purpose of Profit is to understand user behavior and take action on that. If I'm interested in Chelsea Football Club, then I should be pulled into football groups. If I'm interested in trading, then I should be pulled into trading groups. Profit needs to understand both of these behaviors from my side. Facebook as Profit is really good at handling missing data, and what they do is they operate the model to some extent forward, and then you have a change point where something changes, and then things work differently. Another change point, things work differently. It's really a powerful model. It's free, it's open source, it's available for download, which is extraordinary. So if you do micro modeling and macro modeling on a behavioral level, then Facebook's Profit is an amazing model. However, you might be more mathematically oriented, and the ARIMA model does the same stuff, but it's more versatile, it's more general purpose. From my perspective, I find that the ARIMA model kind of matches supply and demand. Well, that's fundamental, because if you can understand those two, then supply and demand sets the price. So connecting the two is very, very important. ARIMA has pretty much all the capabilities of Facebook's Profit if you include the seasonal elements, which makes it SARIMA, and the extensions that you typically use with the ARIMA model makes it SARIMAX. And so Profit or ARIMA, I think they're very, very similar, very powerful, open source, free models that you can simply download and use. There's another way of looking at this, and that's with the state-space model. And one way of thinking about the state-space model is to think about the surface of Mother Earth. That's something we can observe, and deep down inside the surface, deep down inside Mother Earth, we have hot areas, we have high pressure areas, things we've never seen, but which give us what happens on the surface. When a volcano erupts, it's because something happened deep below. What the SSM model does, or the state space vector model does, is to separate the description of what happens in the Mother Earth from what we can observe. And I find that very interesting for EA models, because with EAs, you're interested in the price, but the things that drive the price are very many, often quite complex, and the way they come together is often quite complex. So that nice separation there of separating the underlying world and modeling that from the observed world, I think is really, really, really exciting. So look out for the state space model. That's 3 models so far that we've looked at. We've looked at Facebook's profit, we've looked at ARIMA, and we've looked at the state space model. They're very different models. They do different things. They might get the same result or not. And there's more. We can also look at machine learning, where we build these trees of possible pathways that things can go into. And we can build multiple trees, so you have a decision tree, put multiple on top of each other, you have a decision forest. So machine learning, again, for accuracy and efficiency, for high-speed training, very, very useful, very often used for trading strategies. And we've already seen several machine learning projects outperform the market this year. So that's another one. So now we have Facebook's profit, we have ARIMA, we have SSM, and we have machine learning. All of these fit together underneath the world, or within the world, of artificial intelligence. And there's more. The reason I'm going to tell you about more now is not because I want you to use all of these models. I just want to give you a feeling of how rich this is and how much there is going on in this space right now. So another technology is something called vector auto-regression. It's just one more method, multivariate time series stuff. Again, this can do very similar things to all the other models we've just spoken about. It's very, very powerful. If you talk to a developer who uses VAR, they will say, okay, this is the only one that you will ever need. But your choice of model depends on where you want to go. Let's jump outside. So those are a couple of models that are all applicable to the EAs that we're going to be seeing during 2024. They will be EAs that use every single one of the technologies that we've just spoken about. What are the other guys doing? Well, all the social media algorithms use combinations of these technologies. Why? Well, because social media platforms have very many customers, and these customers have strong emotions. And the way that these social media platforms work is that they try to identify how we feel, they try to identify our emotions, and then amplify them. It's a bit like judo. Someone is coming at you, so you use their energy to do more. So social media algorithms are designed to identify who we are, how we feel, give us what we feel, and then put us in echo chambers. So the technical term for sitting together and having the same opinion is something called an echo chamber. If you go to a dinner party and you listen to someone who's organized a dinner party, then they've said, we're going to invite this one and this one because they always have a nice conversation over there. Then over here, we're going to have these 3 people. They always have a nice conversation over there. Why? Because they like the same things. These guys can all agree about this, and these guys can all agree about this, and they can all feel good. So we have a happy dinner party. And that's what social media algorithms do. They give us what we want. They strengthen the feelings we already have. They put us in echo chambers so that we can strongly agree with each other about how we feel. And boom, we come back the next day, and again, we hear echoes of ourselves coming back. And they have lots of methods of doing this. They look at all our behaviors in order to put us where we want to be. That's the way those algorithms work. Well, how about all these chat GPTs and those things? Well, they're different. Large language models are designed to give us the next letter in a sentence, or the next word in a sentence. That's what they do. And based on everything that we humans have said, they look at, typically after these words, we say this word. Good, so I'll give you that word. And typically after those words, we give that word. So that's how large language models work. They don't understand what they're saying. They are very, very good for descriptive tasks, simple extrapolations. They're even quite good at generating hypothetical scenarios. But they're not good when it comes to rich data. If you look at financial services, if you look at EAs, you need a rich, continuous data sets coming in. That's not what these large language models are designed for. So that's different. But these large language models are super important, and they're going to increase in importance partly because of ChatGPT and OpenAI now launching GPT apps. With other words, on OpenAI, you can now download your own GPT apps. There's going to be like an app store on top of a ChatGPT, on top of OpenAI. What that means is that we're going to be able to control the way that ChatGPT gives us the answers. So an app store on top of ChatGPT, an app store on top of OpenAI. For Apple, it took Apple 12 months from the launch of the iPhone to launch the App Store. ChatGPT have done pretty much the same thing. About 12 months after they launched ChatGPT, the ChatGPT App Store comes along. Boom. And there's more. Microsoft is rolling out its capability, OpenAI capability now inside Microsoft 365 Enterprise. It's available now to 150 million Microsoft 365 Enterprise users worldwide. All the admins need to do is turn it on, pay the money, boom, everyone has access to OpenAI inside Microsoft Word, inside Microsoft Excel, inside Microsoft PowerPoint by default. These things are coming, and they're coming strongly. However, we all know that these large language models, LLMs, sometimes give us really bad results. I have observed hallucinations myself when using these tools, where I ask a question and there's an answer, I check, and that doesn't exist. On this picture, we see a crocodile, and we see a gentleman in the middle, Jack Ma, and we see a unicorn. Now, if I go into any of these large language models, I will find stories about crocodiles, Jack Ma, and unicorns. I haven't seen any of these things. I've never seen a crocodile. Maybe they exist. I haven't seen Jack Ma. Maybe he exists. I haven't seen a unicorn. Maybe unicorns live in unicorn land on the other side of the Big Bang. I haven't seen it, but I don't have the evidence. So there are new tools coming in now in order to prevent hallucinations, because out of the three examples, crocodile, Jack Ma, and unicorns, one of them does not exist in the real world. And there's something called RAG now, retrieval augmented generation, happening within LLMs, where just before it gives you the answer, it bounces the question off RAG and checks to remove errors and just use some external sources of knowledge just to double check. So these tools are improving in quality all the time. Now, okay, so that's a large language model, and underneath that you have a plugin, you have a RAG plugin. Oh, that's interesting. Let's go into that for a moment. There's something called ensemble forecasting, which is happening as well. I said earlier that when you have a big problem, you break it down, you solve each problem, you bring it back together again. Those different parts of the problem can be solved with different algorithms. Sometimes it's just plus and minus, Facebook's profits. Over here we use ARIMA. Over here we'll use the VAR, vector algorithm. Maybe we'll use the state space model somewhere else, and maybe we'll just ignore one. So we bring these things together. We use different technologies to do different jobs. That's called ensemble forecasting, just like a musical orchestra. I just started playing the bass this summer. That's a picture of my Rickenbacker bass right there. I play it very, very badly. Me on my Rickenbacker, not a good combination, should never be included in the same orchestra as what you're trying to do. But my point is that in different orchestras, you have different musicians, you have different musical instruments, and the same thing applies to AI technologies. It depends on the music. It depends on what you're trying to do. Let's take one example from India. So India had a situation where COVID started accelerating really quickly. And the politicians in India reached out to the top universities and said, what's going to happen next? The Bangalore University did a model in ARIMA using NAR, nonlinear autoregressive neural networks, and very quickly gave a forecast for what will happen without a COVID lockdown and what will happen with a COVID lockdown. The politicians then needed to decide, okay, hold on. Do we trust these engineers? Because they're saying some really, really enormous political and economic things to us. A bunch of scientists. Do we trust these people? And do we trust their models? And they decided to trust them. They took action. Of course, there was some logistics, so there was a delay from decision to action. And it turned out that the models that they used, the ARIMA and the NAR models, did correctly predict what happened over the next 50-day period. Very powerful use of these methods, used for mission-critical tasks. This is life and death, quite literally. The thing that I think is going to happen next, over the next couple of years for all of us, is that I'm talking, my voice can be converted to text. We've all seen it, voice-to-text conversion, nothing extraordinary. We've all tried ChatGPT and similar tools. That's text. Okay, so voice-to-text. So voice will be automatically converted to text and fed into these large language models. These large language models can then go to plugins underneath them and work out what to do and then give a response or act on it. We will talk to our computers. Our relationship with our computers will change from being purely keyboard-based to being one of talking. And when we talk, the whole context of everything we've ever said to the computer before will be used by these models in order to formulate a response. If we talk to a good friend of ours who knows us well, then we don't need to say very much. We just say a few words and our friend understands what we mean and gives us the answer. The same applies here. So a couple of questions and our systems will understand the question and give us the answer. Very high level. That will happen over the next couple of years. What's going to happen from a trading perspective is that over the next couple of years, we will talk to MT4. We will say, place a trade on gold. No. Exit my gold position. No. Enter oil. No. Exit my oil position. Stop loss here. Take profit here, use this EA. All of this will be verbal in the future. So large language models, they will dig deep into models. They're going to do the work for us. I think large language models are going to be the user interface of choice for all of us when we interact with the complete digital world. Good. And that applies to more. I'm just going to mention a factory now. If we work for a business which is not a forex trader, then that business will be able to do the same thing. On this picture, we see a woman with glasses, where the glasses have an integrated 5G phone. These glasses do exist, they're not fakes. That can feed directly back voice to text and drive a whole factory. So I'm talking to you, you're talking to me, you are selling me some goods. Good. When you say that that's a deal and we shake hands, your words cause the factory to begin the delivery. So you can be online directly connected to your company, everything connected in real time based on voice. This is coming. So what's everyone doing? Well, boom, big picture. Let's just think about this. Well, we do Google search or we use Baidu to do search. So that's searching the whole planet, the whole world. Google and Baidu, we do general search. From that, we then go into our echo chambers, to our favorite groups of people. Maybe we go into TikTok, maybe we go into Instagram. If we're software developers, we go to GitHub, a company owned by Microsoft. And inside GitHub, there are incredible amounts of ready-to-go software pieces that we can use, other people's work that we can use, enhance, change, and we can contribute. A big group of people. All software developers know about GitHub. If, however, we're building EAs using AI technologies, then instead we go to Hugging Face. So huggingface.co is a new marketplace for AI models. There are 130,000 pre-trained models that are ready to be used and tuned in for your project. 27,000 data sets ready to be downloaded and used. Hugging Face has suddenly become a huge community for AI models. You will find all the most extraordinary technologies within AI inside huggingface.co. I'm not a shareholder in huggingface.co, it's a private company, but if you're looking to build artificial neural networks, it's a really good place to go. It came out of nowhere and it's huge. Now, what's going to happen? 2024. We're looking at 2024. Today, we're talking moving averages, Bollinger Bands, RSIs, MACDs, and Fibonacci's, and so forth and so forth. All right. In all of those cases, we humans had an idea, and based on our idea, we formulated the solution to the problem. The big change that's happening through AI is that we have shared our human knowledge. Our human knowledge is open source from the perspective of all the models that I described on Hugging Face, which means that the models can go directly from human knowledge into an answer. The models do not need to go via moving averages or Bollinger Bands. They can go straight to an answer. The answer might be RSI and MACD, but the answer could be anything else as well. If deep learning predictions were explainable to us human beings, then we would not use deep learning. They wouldn't be used. So there's a big shift. We're going from answers where we predefine the answers to questions where our knowledge form the question and the models give the answer. These are big things. So instead of linear models, table lookups, if-then statements, and fixed rules, we're looking at something very soft. It changes everything. So there will be a transfer here. Some models will continue to work on the basis that we're familiar with now, and then these big things will happen as well. Okay, so where should these sit? VPS is the answer. In all cases, we need processing power and speed. So just like EAs today typically sit on top of Star Trader VPS systems, these new models can require a lot of processing power. They definitely want low latency, so you want to be as close to the liquidity providers as possible. Star Trader's liquidity is amazing. If you look at the average latency, it's just beyond belief how good it is. So you want your EAs to be raw execution speed, super fast, cloud-based, where you can just turn on, scalable, no hardware limits. If you want more power, you can get more power anytime. You want it to be super stable, no local network limits like that. Has to work, something happens in the market, you have to be there. And you want it to be private, so no other applications running on the machine. Dedicated machines for your business on top of Star Trader's VPS. And on top of that, you can put any of these models that we've just spoken about. 2025 will be different. If we look backwards 1 year, 12 months ago, ChatGPT, OpenAI, all of these technologies weren't even heard of. They've changed the world. If we go forward 12 months, everything I've just said is going to be old hat. Everyone is going to know about these technologies. Most of us will be using them. Many of us are using them now without even knowing about it. These technologies are endemic and they're deep in society already. So how about 2025? Well, this morning I reached out to our technical teams, to Star Traders technical teams worldwide, to hear from them how they see 2025. And we had half an hour's chat. I just made some notes. They're on this slide that you can see right now. I'm not going to go through them because they're quite far out. But I'd like to show these notes to you anyway, just to show you how everyone at Star Trader is fulfilling our mission of putting you in the center of our universe. If we want to give you the power of choice, and we do want to give you the power of choice, then before you are in a position where you want to choose this and choose that, we have to preempt that. We have to already develop those technologies so that by the time you say, I want some of this, we've already done it. It's ready for you. So you have a global team to work with. In the city that you live, we probably have an office. We have offices worldwide. Traders choose us typically because we are personalized. You have a dedicated account manager taking care of you. And the diversity of platforms and tools is huge. As you can see from this talk, we're thinking all the time about what tools we need to add to our ensemble. I recommend that you talk to your dedicated account manager about which tools are right for your trading, because you don't want every tool to solve your problem. We all have different problems to solve, so some of us use some tools, some of us use different tools. Copy trade is used by some people, PAM-MAM is used by someone else. Ultimately, customized partner portals are key to what we do. We try to help you build your business. We have a partner sponsorship program, which is big and extensive. We want to talk to you and deepen the relationship and do more business together. That's why I'm talking to you right now. Let's have fun in 2024 and beyond. Thank you.